Just talk while you're doing it.
Yeah, ft, that's the position. And then if you take the derivative of this, it's gonna be the velocity. And that's gonna be 22 minus 12t. Okay? And then you want to know the velocity at time 1 and 3. You calculate 1 and 3. Okay. V1 will be 10. V3 will be 3 is 22, 36 minus 14, right? So the question is asking what's the average velocity between 1 and 3. So it's going to be 10. So it will be, the average will be V1, V3. It will be 10 minus 14. Next minus 2. Negative 2. That's the answer is C. So the concept, you understand?
All you're doing is taking you're taking whatever time it is, and you plug in the first time in the position function, and then
Yes.
placing the second time in the position function, and then you do the difference.
That's the velocity function.
Right. That's
Got
the average
this
velocity.
from here.
Right.
So, and you do the derivative of this function, right? You know how to get from here to here.
We're taking the velocity or the average velocity?
You need the velocity at 1 second.
It says the
and
average
3.
velocity.
Yes, it's average velocity during the time interval 1 and 3. So you need the velocity here and here, right?
Right, that's how you get the average velocity.
Yeah.
And then you would do, because you would plug in the velocity into the position function at time equals those two times that they give you at
1 and 3.
time equal 1 and 3, right? And then you
Yes.
would do
The average of them.
from this function though.
Not
Not the
from-
derivative, because the derivative would be the velocity.
Yes,
So the answer is,
it's minus 2. It's negative 2.
so it is C.
Yeah.
Okay.
Because you want to know the velocity, essentially, at this time point and this time point. Right?
It's just confusing me because it's not saying that in the question. It's saying what is the average velocity?
Yeah.
And the average velocity wouldn't be the derivative. The velocity would be the derivative. The average velocity would be the difference.
You
the
understand
difference of,
that's the velocity, right?
right.
So if you calculate the velocity here and the velocity here, you take the average. It will be the average velocity.
Okay, we could keep going. It's not hard. I know it. I know how to do it. It's just
You use different methods.
for the average velocity, you use a different method. You take the change in position over the change in time.
Yeah.
So
You
it
can
would be
also
the
do
position at 3 and the position at 1 at time.
Yeah.
And then when you get those two times, you take.
That's another way. Yeah, you're right. That's another way to do it. But this is a different way to do it, to calculate the two velocity at two different time point, and you take the average. It's also the average velocity. And your understanding your way to calculate is also correct. So you calculate at 1 second where is it, and then at 3 seconds where is, and then divide it by 2 seconds, right?
That's how I
That's
do it.
that's also right.
So I would get 2 seconds.
Yeah. So from 1 to 3, 1 to 2, 1 second, 2 to 3, another second.
And that would give me 2 seconds? If I do it the way I'm talking about?
You can do it. If it's 1, it's going to be 21 plus 22 minus 6. If it's 3, 21 plus 66 minus 39.
Is it 18? No, 54, yeah.
So here it will be 43 minus 6, 37. Here will be 87 minus 54. It's going to be 33. So here is the last one. The position will be, the distance change will be minus 4. And it's over 2 seconds. So it's negative 2.
That's right. Okay.
So that's 2 different ways. And I mean, in physics and math, you have different ways to solve
I
problems.
know, and that's what
Yeah.
gets on my nerves.
So,
Okay, we can
but
keep
this
going.
way is more straightforward, the way you were suggesting.
Okay.
Yeah. It's good. And next one,
13, 14.
14. So what's the position? You know, it's when it's achieved its maximum speed in the positive x direction. So it'll go only one direction, the x direction, right? The particle.
Mm.
And then it gives to you the position function. And if you draw this function, x would be something like this. So the function is square minus 2. And from this, you will know
Isn't it minus 1.3, 1.0?
1.0. So it's t.
Oh,
The same thing. So at 0, y, this function x is 0. At time 0, it's 0, right?
okay, so you factored out a t squared, and that's how you got 6
Yeah.
minus t. Okay, I get
And
that
then
part.
add a 6.
Okay.
It's also 0. So, and from this we can get the velocity derivative, right? Will be 12t minus 3t squared. Right?
How did you get 12t minus 3t squared?
So you know how to get the derivative from this?
So you're taking the derivative
Yeah.
of that.
So it's
12t.
two,
Okay, yeah, I know how to do that.
you know,
Right.
3t squared.
That would be the average velocity.
That's the velocity
And
at
then you have to-
different time point at the t time.
And then you have to take the derivative, the second derivative, to get the speed, right?
Second to get the acceleration, right?
That would be the second derivative. That would be the
Yes,
derivative of the
yes.
velocity.
Yeah. So it's gonna be 12 minus 6t. That's the acceleration.